Welcome back, everybody. Today we're going to be breaking out the vintage welder in an attempt to weld these axle tubes the correct way. Today, we have a lot to do. Like the title on this video states, we're gonna be welding cast. More specifically, we're gonna be welding the nodular cast iron center section of our Super Duty 60 to its axle tubes. We're gonna be doing this the right way, which involves stick welding or arc welding. Now, I've never stick welded before, so we're gonna be learning the ins and outs of stick welding together, but more on that later. For now, there's a few things we need to take care of. Firstly, I raised the Jeep up to its new ride height, roughly 3/4 of an inch from where it was before. This is as high as we're going. We're gonna make this height work because, like I've said before in the previous videos, I want this build to be low. Secondly, I cut out some inner truss supports for the inner part of the truss. These pieces were very easy to design. I took a chance and didn't make a cardboard cutout first. I just went for it and they came out great. Pieces like these are common for similar trusses on the market. In our case, they just add extra support to our already very strong truss. We've got a lot done so far today, and now we're ready to make our way to the main portion of this video. Like y'all just saw, we raised the Jeep up to its new ride height. In last video, I think I talked about raising the Jeep up at least 1 inch. What I did instead, I just went up one click on the jack stands on all four corners, and that brought it up about 3/4 of an inch. That's as much as I'm going right now. If we need to go more, we'll go more, but we're gonna wait until this axle's back under the Jeep to see if that's needed. Like y'all already know, I don't wanna raise this thing any more than it has to be. I wanna try to keep it as low as possible. And then I also made these, I don't know what they're called, these inner supports for the truss. So what I can do with these is I can tack them into place onto the axle tube. We can remove the truss, fully weld these to the axle tube, and then put the truss back on. Then we can weld the truss to those inner pieces from the outside and then on the top here, just for the truss to bite to, basically. It just adds extra support. That's the same idea behind a lot of trusses, say on Barnes or Artec, and it's definitely gonna make this thing a lot stronger. So now, like I said, we're gonna get to the main portion of the video. Now, I took this axle out from under the Jeep and brought it over here so we can do some work to it. We need to weld this truss into its final resting place so we can basically mount our links up and flex this thing out and see if these lower coilover mounts are gonna work. Now, before we tack this into place, we need to weld the axle tubes. I don't want to have to take this truss off like we have already 100 other times. So that's kind of why I'm finishing the truss today. We're gonna get the axle tubes welded up, get this tacked into its final resting place on top of this axle, and get this back under the Jeep so we can flex it out. Now, welding axle tubes is a very controversial topic. You can do a ton of research on this subject for literal hours and literally make no progress. There's tons of good information on the old Jeep forums, like literally from the early 2000s. There's good YouTube videos out there, but every single source seems to say something different. Even the new Facebook page, I'm part of a Facebook page called 1 Ton Jeeps. That is a group full of a lot of really good information, but you know, everyone's different. Everyone does stuff just a little different, so it's tough to figure out what exactly is right, especially when it comes to this topic. So the reason that this is so controversial is because we're gonna be welding cast iron to steel, and to do that, you have to do it a very certain way, or else it can lead to failures and whatnot down the road. Now, this center section of this Super Duty axle, and as far as I know, every Super Duty axle is made out of ductile. It's pretty safe to say that ductile is basically cast iron. There's a few chemical differences, but we can use the same process to weld this ductile as we would cast iron. To steel, that is. These axle tubes are made of steel, so we're basically gonna be fusing this steel to this ductile, or cast iron. So to do this right, you know, there's 100 different ways. People say, I've done it this way, it's always worked for me. I've done it this way, it's always worked for me. This is the way that works for me, and I'm gonna be doing it the way I'm about to tell you. We're gonna be heating up this center section to roughly, I'm gonna try to get it up to 500 degrees before we do any welding. Then we're gonna be stick welding this. I've never stick welded before. I did some practicing a few nights ago, actually, and I'm very confident that I'm gonna be able to accomplish this. Now, all the welding I've done in the past is MIG welding. You're not supposed to MIG weld this. Yes, people have done it in the past, and it's worked great. I am one of those people who have done it in the past, but I felt like since I'm putting this this out there on YouTube, I might as well try the preferred way, which is stick welding. So I bought some special rods, some special cast iron nickel rod, and that is supposed to be able to fuse the cast iron or the ductile to the steel, no problem. There's gonna be a ton of different ways that you see people doing this. A lot of people won't heat this up. A lot of people will heat this up. A lot of people will TIG weld it. A lot of people will MIG weld it. A lot of people will stick weld it. But the preferred way is stick welding this. All the other welding we do, when we're just welding like fusing two pieces of steel together, that's all gonna be MIG welded. It's gonna come out really nice. But any piece of steel that we're gonna be welding to the center section is gonna be stick welded. I'm sure I'm gonna get at least a few comments that say they've MIG welded the center sections of axles before and have had no problems. I'm one of those people. I've never had a problem doing that, but if I'm gonna show you, I wanna show you the right way. And I'm excited to try something new out. Now, once we get these axle tubes welded, we're gonna set our caster, we're gonna set our pinion angle, and get this truss tacked into place. Then we're gonna be able to throw it under there, and hopefully by the end of this video, we're gonna be able to flex this thing out and make sure at least one of these coilover mounts are right. Now my welder, it's an Everlast 211 SI. I can do MIG welding, I can do TIG welding, and I can do stick welding with it. It's a really, really nice machine, a very high quality machine, but we're not gonna be using it for this project. At least we're gonna try not to. We're gonna be using this old machine that's in the corner of my shop to do this welding. So this is a Lincoln electric, I don't know the designation of the model, probably just 225 amp. So this is a Lincoln electric 225 amp, according to the sticker. This machine was my grandfather's machine. This is an old machine. This thing is probably much older than me. And today we're gonna be using it to weld up the axle tubes on this axle. This machine's also older than that axle. This hasn't been turned on, if I had to guess, in probably about 15 years or so. Up until 2 days ago, I turned it on just to make sure this was actually gonna work for this. I did some practicing with it, and I think I got a pretty good grasp on stick welding, so we're gonna go ahead and try it out today. I wanna use this machine rather than my machine I usually use, my Everlast, because like I said, this was my grandfather's, and I think, it's probably not gonna get much more use out of it in its lifetime. I think it'd be really cool if, it sounds corny, but if he can be part of this build in some sort of way, and I think this is the way to go about that. If this fails, then we can always fall back on stick welding with the Everlast. Anyways, let's get this machine plugged in and get to welding up those axle tubes. This actually came out really good. I'm surprised that that machine worked as well as it did. For my first time stick welding, all of the welds came out pretty nice actually. In the spots that it didn't look all that great, I just did another pass and it kind of cleaned it up. So all around the tubes, it has about 2 passes. Aside from looking good, the more important part is that it penetrated well. By looking at it and looking at the puddle as I welded it, I'd say we got some good penetration and some good welds. So now it's time to move on. We can clean this up now and get that truss tacked into place. Now I should address the possible concerns some may have on heating up this axle like I did, and whether or not it could bend or warp as a result of the heat from the torch or from the welding. This axle still has gears, a carrier, and seals in it. I left all that inside, and I always do this to make sure this axle is as rigid as possible to combat any bending or warping. Our expensive parts aren't in here yet. We'll be putting an ARB air locker along with 538s in here. I probably wouldn't have heated up or did the welding with those parts in there. Along with that, I welded each tube in 4 sections. I welded one section, rotated the axle, welded the opposite section on the other tube, and I kept doing that until both tubes were all welded up. I then finished it off by wrapping it in a welding blanket overnight so it cooled down nice and slow to help greatly reduce the chance of cracks. I took the truss apart, made sure it was completely square with itself, and welded it up for good on the inside. I also did a few spots on the outside, but we're gonna come back to this and we'll be completely welding the outside later on. This is a weldable primer. That's what I just sprayed onto there. Once this is finally assembled, once that truss is welded onto the axle, we're not gonna obviously be able to paint on the inside of it or on the top of the axle. So I went ahead and I sprayed some of that onto there just so it doesn't rust in the future. I went pretty light on the axle, just one quick light coat. And then on the underside of the truss, I went a little heavier, but still just a nice quick coat. We're gonna let this cure for just a few minutes, probably 10, 20 minutes, and then I'll go ahead and get that tacked onto there. Now in the, I think it was the 3rd video in the series where we actually built this truss, I talked about how I was setting up the pinion angle on this axle when it's gonna be at ride height under the Jeep. Like I said in that video, for a double cardan drive shaft like we're gonna be using for this front end, you want this pinion pointed straight at that transfer case. But there is a measurement that is arguably more important, and that's our caster angle, and I didn't touch on that in that video. For a setup like this, there's a lot of numbers on the internet. You want 6 to 7 degrees of caster. I also have seen 8 to 10 degrees, but we're gonna shoot for 6 to 7 degrees. Basically what caster is how far back this axle is rolled. We need to have the right negative caster or else our front end is gonna do a lot of weird things on the road. Having negative caster is what pulls your wheels back to straight after you're taking a turn, so it's very important. A lot of cases of death wobble can actually be solved by correcting your caster. Say when you lift a Jeep, for example, if you're just doing a short arm kit and your suspension geometry is not correct, it can move that caster, say to 0 or maybe even positive, which is really bad, and that makes a good recipe for death wobble. So for this setup, for this junkyard Dana 60 axle, we definitely want our caster to be correct. So I'm gonna set this caster to about 6 to 7 degrees. I'm gonna do that by just using this angle finder. We're gonna throw it on the top of the C right here, and that reads right now 6.5 degrees. Now, with that being correct, our pinion angle isn't going to be correct anymore. At ride height, it's gonna be pointed a little further down than desired. It's not gonna be completely pointing at that transfer case, but it's a sacrifice we're gonna have to make because arguably the caster is a little more important. Now, the way to fix that, to get the pinion angle dead on along with the caster, for this junkyard axle in particular, we would have to retube it and then reclock the C's. We're not getting that in depth on this build. I'd like to do that eventually for maybe a build in the future, but for this build, this is gonna be just fine. But for example, if we were to do that, before we welded the tubes, we would have drilled the plug welds, pulled the tubes out, we would have retubed this to whatever length we wanted to. It actually would have been pretty nice. We would have set our pinion angle under the Jeep, weld the tubes up, and then we'd be able to set our caster perfectly with the C's and weld them back on. Like I said, I'd like to tackle that one day on a future build, but for this build in particular, this is perfectly fine. So right now, I have the caster set to 6 degrees. This is the pinion angle, like I said, is a little low, and I'm going to set my truss to 0 degrees on top of this axle, which, wow, that's actually already on there. That's awesome. 0 degrees. It's 0.5 degrees actually, depending on where I put it on. That's 0 degrees right there. Within a degree or half a degree maybe is my preference. Some people don't like to set them at 0 for certain builds, but that's just my preference. So with that at 0 degrees, with our caster correct, I'm gonna go ahead. I'm gonna tack on these little inner supports right here on both sides. We're gonna pull the truss back off. I'm gonna fully weld those on the inside. Then we're gonna put this truss back on and get it tacked into place. Not even tacked. I think we're gonna throw some legit welds on there. All right, so this isn't fully welded up right now, but it's not coming off anymore, at least. You can see we've got some legit welds down here on the bottom. I got 6 of them. I'm holding it down to the axle. 4 over here on this tube. Then we've got 2 on the ends here on both sides. And then I also went ahead and filled in basically this rectangle. I filled in these 2 right here because we're gonna be welding on the upper control arm mount once it gets under the Jeep. These ones I'm gonna leave open for now. We're gonna get to those later on, as well as finishing welding literally the rest of it. We're gonna leave that for later on. I don't like to finish weld anything until everything is done and needs to be finish welded. So this is partly finish welded now, but we're gonna stop here and we're gonna get it under the Jeep. Next big project, mark my words, I will be building a contraption on wheels to move axles around, as well as better precisely lift and lower them under the Jeep. I've been talking about this for years, but just haven't gotten around to it. I think my back and knees will thank me in the long run. All right, the axle is completely square out here under the Jeep. We've got the plumb bobs on the frame right here, and this truss is zeroed out. Right there, 0.5 degrees, that's perfect. Our caster is set at 6 degrees, like we said before. This axle is right in its right spot. Now we gotta go ahead and make some temporary links before we can flex this thing out. An issue I'm already seeing is that right here, this upper link, this is the old upper link. We're still higher in the front here than we are in the back, and that's a problem. I already have the Jeep up as high as I want it to go. I don't want to go any higher, so we're gonna have to redesign the upper link mounts. In the last video, we made this bracket here for up top. This is a really nice bracket. I was hoping we were gonna be able to use this. We might still be able to, but I'm not sure. I'm not completely positive on that. So right here, you can see I got the temporary link. And right here, a big problem about this is that link is so close to the floor. You can literally actually see where the link came into contact with the floor previously. So that's a problem. So we're gonna fix this right now. We're gonna take off this outer piece of the cross member. This is the 3-piece cross member we made about 3 years ago. It's really nice, but I never liked that upper frame mount bracket on the outside piece here. So we're gonna kill 2 birds with 1 stone, and we're gonna redesign that all together. We're gonna take off this upper bracket, we're gonna cut off that upper mount, and we're gonna try to drop it down as much as we possibly can. It's already, once it's off, you'll see that it's already really, really low, but we're gonna try to bring it even lower. Now that should bring this number right here. What is it right now? It's at 2.6 degrees. I know you guys can't see that, but it's 2.5 degrees. Lowering the frame side mount along with making a new upper mount over here, it's gonna be very similar to this one. We should be able to drop this, make that angle 0 degrees. Now we gotta be careful because once we drop this, it has a better chance of interfering with the drive shaft, so we just gotta keep that in mind. There is a lot going on down there, that's for sure, but I know we can make everything fit down there. We just gotta try a little harder. So let's go ahead and get that cross member off. So here is part of the cross member. This is the middle part of the cross member because that's a 3-piece cross member that's inside of there. And here's the driver's side actually. We got the skid plate that we made a few videos back. You can see we got a Backcountry Beagles logo on there. And this is the driver's side part of the bracket. This is the part that has the upper control arm attached to it. We're gonna be replacing this upper control arm mount. I made this about 3 years ago. I was never really a fan of it. We're gonna just redo it. It's probably gonna be pretty similar. I don't know. I have a lot going through my head right now and how I want to do that bracket, so we're going to come back to that. We're going to work on the axle side bracket. Here is the upper control arm mount that we made a few videos back for the axle side. This is a really nice mount, but I think we're going to redo it. We're going to drop this mounting hole for this bracket down about 1 inch, and we're going to see if that fixes our angle problem that we have on that upper link. I've got a lot going through my head on exactly how I want to go about this, so it changes like literally by the minute. So I'm gonna go ahead and I'm gonna make an upper bracket for that axle side, and I'm gonna let you guys know how it comes out. This is the beauty and the fun of building a full-bodied rig like this. Real estate under the rig quickly gets taken up, and trying to find solutions to problems that arise from this is challenging yet worthwhile and rewarding in the end. If all goes well, all of these parts that we're fabricating will function together in a reliable and capable fashion, and as a result, this Jeep will be able to accomplish extremely difficult trails with ease, and more importantly, take us to some pretty amazing places. So we got the upper link mount on the axle all welded up. It's actually welded up to itself and tacked onto the axle. I like this bracket a lot better than the one we originally made. It's very similar, but it's much shorter. What I did was I moved the monolocation for the link down 1 inch, and by doing that, I had to move it forward a little bit, which is totally fine. Actually, it's actually better because now it's better in line with the lower control arm mounts. This bracket is only 3 inches tall. The other one was 3.5 inches tall. And now the best part about this right here, 0.5 degrees. This is 0.3 degrees. This is basically at 0 degrees, which is perfect. I haven't touched the frame side upper link mount. Like I said, I got 100 things going through my head and it changes by the minute. I'll try to keep you all updated as best I can, but it really does just change so quickly. This is looking really good though. I'm gonna get to work on the lower link so we can finally get this thing flexed out. And another thing that is actually really cool, you can see this drive shaft and this upper link are very close, but I think we're gonna have enough room between the two of them. We only need 5 inches of up travel, so hopefully we can make that work. All right, we've got all our mounts tacked into place. We've got both the lower control arm mounts tacked into place. We've got that new upper control arm mount tacked into place. We've got this coilover tower. I went ahead and re-tacked it just so it's nice and strong now. It's got 4 tacks on it. We've got the coilover in, it's centered in the hole. The top of it, we've just got it held on with a bungee. This is not how it's gonna be, obviously, but this is just for test fit. We're gonna go ahead and raise this side up first. We're gonna go ahead and raise it up 5 inches. And how I'm gonna determine that, I'm just gonna measure from the ground up to the center of this bolt right here, which right now it's 18.5 inches. We're just gonna go up 5 inches from that. And we're gonna see how that coilover looks on that side and see if it's gonna hit the mount or come into contact with it. Then maybe we'll take it a step further. We definitely will have to. We'll drop that side, while this side is up 5 inches, we'll drop that side down 9 inches because we're gonna have 9 inches of down travel, and we'll see if we have any problems there. And then we'll go ahead and switch. We'll raise up that side and lower this side, see if we have any issues with the drive shaft contact in this upper link. But yeah, let's give it a shot. This is pretty exciting. Got that side up 5 inches. It's actually about up 5.25 inches, so it's a little taller than it needs to be. That's fine. And right here, we're still square inside of that hole in the center. We haven't contacted here on the coil mount yet, so that's good. But you can see what I'm talking about, where everything's really tight up here. So see the exhaust right here. We got the O2 sensor. That mount is very close. But like I said, we're up slightly higher than we need to be by about 1/4 inch. I can still get my finger through there, so I would be fine with that. And then, I don't think you guys can see it, but back there near the floor, oh yeah, you kind of can, right? Right there, kind of. You can see where it's kind of pointed. It's slightly touching the link. And so we're probably gonna have to do some work to that floor right there in that one spot, because this piece of PVC that I'm using as the upper link is actually much thinner than the DOM that we're gonna be using. We're gonna be using 2-inch quarter wall DOM for all of these links, the uppers and the lowers. And this PVC, I'm not sure the diameter of it on the outside, but it's much smaller than 2 inches. We've got another 2 inches to go. Nine and a half. All right, we've got 9 inches of down travel over here, 5 up over there on the other side, and we've got no interference with these lower coilover mounts. That was my biggest fear, was that this part of the coilover, let me zoom out for you, that this part of the coilover was gonna contact right here. But it looks like that's not gonna be an issue. That's really good news. No issues with anything over there, so I'm gonna go ahead, I'm gonna snap a few pictures of this. It looks pretty cool. We still got this centered up here in that hole. That's pretty good. I'm gonna go ahead and bring this back to ride height, and then we'll bring this side up to full bump, and then that side down to full droop. No issues. That's what I like to hear, at least as of right now. I was afraid we were gonna have to remake brackets, but everything is looking really good so far. Aside from the suspension functioning real well, it looks amazing under the Jeep. This thing is going to look crazy climbing over the rocks in Moab in a few months. I know just the trail we can test all this out on once the time comes. Also, when I flexed the axle into the other direction, we had no clearance issues. Now that we flexed out the Jeep, it's safe to say that those lower coilover mounts are gonna work. So I'm gonna go ahead and get another mount cut out for the other side, but we're gonna be ending the video right here since we already made lower coilover mounts in the other video. I don't need to show you all again. This was a very cool video. We got a lot done on the Cherokee, and I was able to stick weld basically for the first time with success. That's good. I'm not sure what the next step is. I'm thinking we're obviously gonna get some DOM links cut out for this and possibly make the upper coilover towers. I'm not sure what I wanna do first, if I wanna do the coilover towers or the steering and the track bar. I wanna flex out the Jeep with the tire on it and make sure we're not gonna have any interference with it, because that could turn into a big headache. I'll see what the budget this week is like. As always, I appreciate y'all for watching. I'm having a lot of fun in filming this series and fabricating all this stuff for the Jeep for y'all. We got a lot more coming for this Cherokee, so be sure to stay tuned. As always, I appreciate y'all for watching. I'll see you on the trail, and I'll see you next time.